my name's Dave, and this is, yes, part 7 of the series on methods. I know I said in the last part that part 6 would be the last, but once I finish, I realized there were a few more things that I really wanted to cover. So, but I do promise this time, this is the final video on methods. So this is part 7 of methods, and I'll try to make it quick. Just a few things. I want to talk about named arguments. And this is a way, generally when you call a method that has parameters and you pass it values, it's passed positionally. So let's use this, go back to this introduce yourself method. So I'm going to go ahead and call this method introduce yourself. And it takes two strings, a string, an int, and another string. So I'm going to pass it Dave, and then my phony age, and fave, actually let's just put in taco here, string. Okay, so I'm calling this method, and we know that the argument these are the arguments. These are the parameters, right? Input parameter boxes, right? So this gets assigned here. This gets assigned here. This gets assigned here. So this is the first position, second, third, right? So it's done positionally. But if you don't want to do that positionally, you could do something. You could use the named argument. It's called named argument. And here you just put in, and actually let's go ahead and delete these. You can type in the name of the parameter. See how it pops up here? This is the parameter name, and you can see here it says parameter, string name. So you can type this in with the colon there. So name, I'm just going to click on that, or you can hit enter. You want to have the colon, make sure you have the colon, that's the syntax for this. Now I can put in my name, right? And also you don't have to follow, it's not going to put it in positionally, so you don't have to follow the position here because you're using the named argument. So instead of age, which is the second parameter, I'm going to go ahead and put in food, right? So colon, this takes a string, and I'll just put in taco, and then now I can put in age, and close enough, right? Okay, so now I'm calling this method, but I'm using a little different syntax here. I'm using this named argument, where I just type in the parameter followed by the colon, right? Followed by the colon. And this isn't something I've used a lot, but it's another tool in your toolbox, right? Just another tool in your toolbox. And this is a way you can pass arguments, pass values to the parameters without having to line them up positionally. You can get around sending it by position, right? Passing it by position. And also it could make your code a little clearer. You know, when you look at this, you say, hey, this is the name parameter, this is the favorite food parameter, this is the age. So you can use it for that, just clarifying your code if you're calling a method that has several parameters. So that could be one use for it. But also if you don't want to, for whatever reason, you don't want to follow the position, then you can just use the name arguments, right? So I don't know if it's something you use a lot, but it's another tool in your bag of tricks, if you will, in your well, let's go ahead and run this. I might as well. Yeah, another tool in your toolbox, right? And we'll just go ahead and run this, and there we go. And it works the same way, right? Okay, so let's talk about optional arguments. Optional arguments. This is a way for you to give default values to your parameters. And let's look down here at this method. Get random number. Note that I have default values for my parameters now. I have default values. This is a parameter that takes an int, and this is a parameter that also takes an int. But note the equal sign, and the default value here, right? Equal sign and default value. Here I'm assigning these parameters default values. I'm giving them default values, right? Now when I pass, and let's go ahead and call this method, get random number, Control C, Control V. Okay, so I'm going to go ahead and pass these parameters a value, right? So let's go with 50 and 500, right? So 50 and 500, and I'm going to just put a breaking point in here. Just put a breaking point there, and let's go ahead and run this. Okay, so and now look, in this input parameter box holds a value of 50, not 0, holds 50, right? As you would think, right? As normal. This holds 50, which is what I passed it, right? 50 and 500. I mean, so the first parameter holds 50, and this parameter holds 500 because those were the arguments. Those are the values that I passed it, right? Which is what we would expect, right? And then we know what the random type does. Just returns a random number. All right. So let's go ahead and stop that. Okay, next time I'm not going to pass it a value. I'm not going to pass it a value. And let's go ahead and just create a variable. Okay, so this time I'm going to call this method, but I'm not going to pass it any value. It has two parameters, but it's okay with me not. I'm not getting the red squiggly, right? Even though it has two parameters, because it has a default value, right? So let's go ahead and run this. I'm going to get a random number. I'm just going to use the default values here, and I'm going to print that random number to the console, or the output window rather. Alright, let's close this, open up the output window. Again, if you don't see the output window, you can go to Debug, Windows, Output. Alright, so output window, and we can see it got a random number, 621, right? So the random number it returned. And it did this without me passing it a value. Now look what happens if I do something like this. If I get rid of that default value, now I get the red squiggly, right? Now I get the red squiggly, and it's saying no overload for method. For the method takes 0 arguments, so we have to pass it a value now. But if we give it a default value, then it's okay with you not passing it a value because it's got a default. It figures, well, okay, you're not going to pass a value to this parameter. I'll just use this default. That's cool, you know. So if you have a default value, it'll just use that. If you don't pass it a value, if you do pass it a value, then of course it uses whatever you pass it as you would expect, right? Okay, so let's talk about something called a helper method. Helper methods, and helper methods are methods that help other methods, right? They're helper methods. They do pretty much what it sounds like. It's a method that helps another method, basically. It does a little something for the method. And one thing to keep in mind when writing methods is that you want your method to only do one thing. You pretty much only want your method to do one thing. If you've got this one method and it's got 50 lines of code and it's doing all kind of stuff, then that's a spaghetti code. It's bad practice because it makes your code a lot more difficult to understand. It may be fine for C#. The compiler could care less, but you want your code to be easier for you to read, right? And some of the stuff that a method may do, you may want to reuse with other methods, right? So let's look at an example. We're going to do something. We're going to take you back to geometry class, and we're going to get the perimeter of a rectangle, right? This is the formula for the perimeter of a rectangle is 2 times length plus 2 times width, right? 2 times length plus 2 times width. So I've created a method here that does that, and we want it to return inches. We want it to return in inches. So we want to get the perimeter of the rectangle, and we want it to be in inches. We're going to pass it the values in feet, but we want to get the value in inches, right? So I've got the formula here, right? 2 times length plus 2 times width. Note that the parentheses really aren't necessary here. I just threw them in there for clarity, for my clarity, really. But C# follows the order of operations, so this isn't necessary. If you view the video on arithmetic operators, it talks about this. So in this case, the parentheses are not necessary, but I like to put them there just for clarity's sake. So this is my formula, and I'm going to pass the length of the rectangle and the width of the rectangle, right? These are my parameters, and I'm just using the double type, right? So note that I named the method get rectangle perimeter in inches, right? Pretty descriptive, and you know, it's also think about it. Note this syntax right here. These are XML comments, called XML comments. And if you want to give a summary, it's a good practice to do this. If you want to do this with your methods, you, type in 3 forward slashes, and this will pop up for you. And then you can type in a little description of your method, right? So Alright, converts feet to inches. So there's just a little description of your method. So this is called XML comments. So just 3 forward slashes, and it'll create a little stud for you or whatever. And if you have returns, it'll put that in here. It puts the parameters in here. Param is short for parameters. So it gives you a little summary of the method. And also, when we get an object-oriented programming and you create an object of this class, this will show up in IntelliSense. So this gives information to IntelliSense also. So I just want to throw that at you while I was thinking about it. Okay, so back to our method here, get rectangle perimeter in inches. So this is the formula that gets the perimeter. But we don't just want the perimeter, we want the perimeter in inches. We want the perimeter in inches. And we could put the method here, right? We have this code here which gets the inches. So we could do something like that. We could use that here, right? But if we do that, then this method is really doing two things. It's getting the perimeter and it's converting the feet to inches. So we're really doing two different things. We could do it like that, but we're doing two different things. And what if we have other methods that need to convert feet to inches? Then we got to write the same code, you know, in all of those methods, right? Every time we need to reuse that. So this is something called refactoring. You're refactoring the method, which basically means you're setting up your methods where they only do one thing. You only do one thing, and if the method needs something else done, like convert to inches, then you can create a helper method. So we could call this a helper method, right? This method is helping this method, right? This is the method we're calling to get the perimeter in inches. So we don't actually call this method. We could, but we don't actually call this method. And note too that I went ahead and made this private. So this is a private method. And we're not too concerned with what that means exactly. We have to get into object-oriented programming for that to really make sense. But I went ahead and made this private. Generally, helper methods are going to be private. And note that I'm using camel case. Camel case, the first word is not capitalized. The rest of the words are capitalized. That's camel case as opposed to title case, where all the words are capitalized. So I'm using camel case, and that is a convention for private methods. It's a convention for private methods. You don't have to use that. I think it's a good idea, because whenever you see a lowercase or camel case rather in your code, then you know, hey, that's a helper method. That's a private method, right? So it's just a good idea. It's a good convention. So camel case for private methods, title case for public methods. Just one convention, right? So okay, so we're calling this method, and within this method, it's calling right here, feet to inches. It's calling this method, right? It's calling this method, right? So we're calling this this method. Within this method is calling this method. So this method is helping this method, right? It's helping it out, right? So this is a helper method for this method, and it could be a helper method for other methods that need to do the same conversion, right? Feet to inches. Okay, so I'm calling my method here, get rectangle perimeter in inches. This is by my method that I define here. I'm given, for the length, I'm passing it 20. So I have this rectangle that's, the length is 20 feet, right? 20 feet. And the width is 5 feet. 5 feet, right? So I'm passing it these two values to these parameters. So these parameters are going to hold those values. And then here I'm performing the calculation, right? 2 times length plus 2 times width. That's the formula for finding the perimeter of a rectangle. So okay, it gets that. It gets the result, puts it in this variable, right? Called perimeter. And then I call my helper method, feet to inches. I pass it this perimeter, right, which is in feet, and I pass it to the helper method, feet to inches, and that converts feet to inches, right? Just feet times 12, of course, and that returns inches to this variable, and then I just return this variable, right? And that gets returned to this variable, which is a different variable, right? These are two totally different variables. This variable is within the scope of this method. This variable is within the scope of this method. These are two different boxes. They happen to have the same name, but they're two different boxes, right? And C# knows which is which because of their scope. This is within the scope of this method, right? This method. We see we got all this old stuff we done commented out, but it's this method. This is the scope of this method, right? So this is defined within this scope. This is defined within this scope. Even though they have the exact same name, they're two completely different boxes, right? Two completely different boxes. This is for this method scope, and this one is for this method's scope, right? So I just want to point that out. So we're calling this method, and it returns the perimeter in inches, and then we're going to print that to the console. So let's go ahead and run this, and set up the debugger, set up the breaking point rather. You click over here or press F9, either way. So let's click on the button to execute this code. Okay, so we want to do the step into, right? We've done this before. Step into, because we want to step into this method. If we do step over, it's just going to run that method. Do what it do. It's going to tell it to do what you do, and then just keep going, right? Let's go to the next line. Do what you do, and then go to the next line. Whereas step into means step into this method, so we can walk through the method, right? So let's do step into, because we want to step into the method. So step into, so now we've stepped into the method, right? Okay, so let's look at the values. 25, those are the values that I passed it, right? 25. So these input parameter boxes hold the values that I passed it as expected. And this formula, and let's go ahead. So 40, 2 times 20 is indeed 40, 2 times 5 is indeed 10, right? So we've added these together, so now we got 50 feet. So we got 50 feet, so this variable holds 50 or 50 feet, right? And let's step into again. Now we want to step into this method, feet to inches. And let's step into this method, right? So now we've passed it 50, right? Passed it 50 feet. Let's return 50. We assigned it to this variable. We pass this variable, which holds 50 in this case, to this method. right? And now we do our formula for getting the inches, feet times 12, right? And just keep stepping, and now it's 600. So 12 times 50 is 600, so it's 600 inches. We converted the feet to inches. Now we're just going to return that, right? I'm just going to keep stepping. Now I can do step over. And also, if you wanted to step out of the method, you step out, right? This would step out of the method, right? This steps into the method. This steps out of the method. And this just executes and goes to the next line, right? Okay, so we got perimeter in inches. So now we've got that. So now let's keep going, and now it's going to return the 600, which is inches, right? So this is return this to this variable, right? It's got this return that value to this variable, and now we're calling this right line, the static method right line, that prints it to the screen, and it should be there. So there we go, 600, right? It's print to the output window. Okay, so now I want to give you a demo on generic. I want to introduce you to generics. It's something called generics. And basically it allows you to create code for any type, for any data type, right? So let's look again at our swap method. The last time we swapped strings, right? We had the type, and we know what the ref is. We covered that. So the last time we put in the actual type here, string, and it could be int or whatever. But in this case, we're going to use generics. We're going to use generics, and this is the syntax for generics, right? These angle brackets with a T. T stands for type, right? T is just short for type. So the angle brackets and the T. This is saying this is good for any type. You could use this for any type. The T there, any type. Doesn't matter if it's an integer, a string, a double, whatever, whatever type it is, it's good for, it's generic, right? It's generic. So that's the idea behind generics. But think about, if we wanted to swap integers, strings, and doubles, integer strings and doubles, without generics, we'd have to write a method for each one, right? We'd have one define, the parameters would be declared to accept a string. And the other one, the parameters would be declared to accept ints, right? And the other one double, etc. So we'd have to write three different methods. We'd have to write a method for every type we want to use this code for. But generics allows us to write one method, and using generics, using the syntax here, angle brackets with a T, right? And the T is now the parameter, or parameter type. It's the parameter type, right? So T is the parameter type, which means it's generic. It can be any type, right? And you have to have this in order. If you don't have this, then the T is not going to work, right? So let's delete that. And the T is not going to work there without you have to have the angle brackets with the T. So that tells it to use generics. Now the T is basically is generic. Any type, can be string, int, doesn't matter, right? So now let's use the T again. We can reuse that T, which is generic type, right? So because of this, it's now T, the capital T is now generic type, so any type. Okay, so we get value 1, and we just put let's rename that temp. And this isn't necessary in this case, but actually it was. Yeah, we got it. Okay, never mind. Okay, so the same as before, the swap method, remember that, we put it in a temp box or a variable called temp, and then just did the old swap-a-roni, right? So I'm not going to go over the algorithm again, but basically we can do this with any type. So let's test this. Okay, so I have two values. I'm using int type now. I'm just using the int type. And so I have value 1, value 2, and again, these are different variables than these, right? Different scope. So we're using the int type. So the value 1 is 5,000, value 2 is 2. And note that I'm using the ref keyword. Got to do that in this case. We're passing by reference, right? So I'm passing it these two variables to these parameters, right? Same name, but different boxes, right? So I'm passing these variables to these parameters, and it's int of int type, right? But I can use any type because of this syntax here, these angle brackets in capital T. The T is short for type. So just, any type. I can pass any types. Let's go ahead and let's run this. So value 1 is 5,000, value 2 is 2. And now we can see in the output, value 1 is now 2, and value 2 is 5,000, right? So here value 1 is 5,000, here value 2 is 5,000. So it swapped them. Right? It did the old swap-a-roni, and it did it on ints, right? It did it on ints. So let's comment this out. Now let's try it on strings. Let's try this on strings. Okay, so now I have strings instead of ints. So now we're going to try to pass it strings and see what it do. All right. So click on the continue button. And there we go. It did the old swap-a-roni once again, this time on strings. So that's just a brief introduction to generics. This is the syntax for generics. And you've seen this before with lists, by the way, if you've seen the video on lists. Same principle, same idea there. That's using generics. So this is the syntax for generics, the angle brackets with a T, capital T in there. And then we can use this T to basically means any type. So any type. So this is a way that we can write code that's good for any data type, right? Okay, in the last demo, a lot of times what we do with a conditional test, sometimes you'll call a method for that conditional test, and instead of doing like a comparison or something like that, sometimes you'll call a method. It's something that we do quite a bit. So let's look at this method. Let's go first. Let's go to the design view. Let's go back to the design view, and note that I put a checkbox. Went to the toolbox and checkbox. Right, checkbox. Left-click, drag onto the form, or double-click, either way. And in the properties grid, I just kept the default name. That's good for now. And the only thing I changed, the only property I changed was the text property, right? The text property, and I just changed it to hot outside. Hot outside. So if it's hot outside, you'll check that. If it's not hot, you'll keep it unchecked, right? So let's go back to the form. And the way we find whether or not it's checked is we use the name of the checkbox, which in this case is checkbox 1, right? It's the default name. So we use that. We use the dot, right? The member access operator, the dot, and it has several members. One of its members is a Boolean property, a property that holds a Boolean. And again, you can think of properties as variables for now. So the check it gives you it's a Boolean type, so it's either true or false. So if it's checked, it's going to be true, right? If it's false, if it's not checked, it's going to be false. So this checks to see if that checkbox is in check. If it is checked, then what this method does is returns a bool. It returns a bool, either true or false. So if that checkbox is checked, this method returns true. If it's not checked, otherwise, then it's going to return false, right? So if this conditional test is false, then it's going to execute this code and return false, right? And this is a conditional test, right? It returns true or false, and all conditional tests return true or false, right? It's either true or false. So anything that returns true or false can go in here and be used as a conditional test, right? So that's what we're doing here. We're checking this. This is a Boolean property, so we can use that here. It's true or false, right? It's going to return true or false. So if this is true, that checkbox is checked, then it executes this code, and what this does is return the Boolean literal true. So if it's not checked, it's going to return the Boolean literal false. So let's try this out. I'm going to do an if statement. If tab, and I'm going to go ahead and type. And note too that I've made this private, and I'm using a camel case. So it's private. It's a helper method. It's a private method. And I'm using, since it's private, I'm using the camel case. I'm just sticking with that convention. I like that convention. I don't always stick with. Sometimes I forget actually, but I like that convention. So I'm going to try to stick with that for now. So if it's private, camel case with methods. If it's public, then title case, right? So is hot. This is a method, so we have to have the parentheses, right? We don't have any parameters. We don't have a parameter signature, but we still have to have the parentheses. All right, so it's a method, so we still have to have the parentheses. We always have to have the parentheses, whether we're passing it values or not. In this case, we don't have a parameter signature, so we don't need to pass it values, but we still have to have the parentheses, right? Still got to have the parentheses. Okay, so if this method returns true here, then let's do a message box dot show, right? Throws up the little dialog box, and I would say go for a swim, right? So if it's hot, go for a swim. So if this returns true, we'll get this message box, the pop up, and it says go for a swim. So let's check this out. Let's go ahead and run it. Okay, so I'm going to leave it not checked for now. This time, click go, and nothing happens, right? So let's click on, let's go ahead and click on it, so it's checked. So now this checkbox is checked. So now when I click it, we should get the dialog box, go for a swim, right? So let's look at this in the debugger, and I'm just going to put a breaking point right here. You can click over here or F9. So now let's run this again, and we'll go ahead and check it and execute this code. So now we're stopped here at our breaking point, and again I'm going to do step into. So I want to step into this method. I want to step into this method, right? I don't just want to run it and keep going. I want to step into it. So now we can do the step over. So now it's checking to see, it's checking that property on the checkbox, that checkbox 1 property, to see if it's checked. If it is checked, then this is going to hold true, right? And it is indeed checked. And since it's checked, since this is true, since this property is true, so we have a true value here, right? It's the same. It's the same as this, right? It's same. All right. So this holds true. So now it's going to execute this code, this if block, this code block here. It's going to execute this since this is true, and it's going to return true, right? So now this is going to be true. So now that this is true, now it's going to execute what's in here. All right. So it's going to execute this code block. And this message.show just throws up the dialog box. There you go. It says go for a swim. Okay, that's it for part 7, and I promise this really is the last part. Thank you. I know this is a long one. Thanks for hanging in there. Kudos, and I'll see you in the next video.